Good afternoon, all. Now, children, I think you are busy with board practicals, isn't it? So please study the concept before going for the practicals and study all the circuit diagram, ray diagram, everything necessary, please study. So all the best for your board practicals, children. Now, I'm welcoming you to the 1 mark solution again. So please subscribe, like and share to all your friends. So let us start with the third unit, magnetic effects of electric current and magnetism. Of course, you know that, children. Here, the first, second, third unit all are linked each other. The first unit only the charges at rest. That means they are taking rest. That is why electrostatic, static electricity. And in the second unit, it starts flows. So it starts flows, we are getting current. Then again, we can say when current is there, around the current, we can say that, or around the moving charges, we are getting magnetism. That means magnetic effects. So we are dealing with the third unit, the magnetic effects of electric current and magnetism. So let us start with, children, with the first assertion and reason. The first one, assertion. The centripetal force on the test charge Q0 is Q0 VB, where V is the velocity of a particle and B is the magnetic field. Of course, all of you know that, isn't it? What is it? When a charged particle is placed in a magnetic field, it will experience a force F is equal to QVB sine theta. So, if the velocity and the magnetic field are perpendicular, we will get the maximum force QVB. So, centripetal force, why the centripetal force? We can say that when it is in the perpendicular direction, that means velocity and magnetic field is in the perpendicular direction, they will be moving in a circular path. For that, they have to get a force, that is centripetal force. The centripetal force is provided by this magnetic force. So that is why here it is written the centripetal force on the test charge is Q0VB. That is a maximum force they are getting because theta is 90 degree. Then what is the reason here? When a charged particle is fired at right angles to the magnetic field, the radius of its circular path is directly proportional to the kinetic energy. No, the assertion is true, but the reason we can say that it is not true. That means radius is not directly proportional to the kinetic energy. So the option C here is C. And the assertion and reason option, you know that the first one is both are true and the reason is not the correct explanation for the assertion, and the option B is not correct explanation, and C option we can say first one is true and the reason is false. Both assertion and reason is false. We can go for D. So first of all, you should know all these things. Then we can go for the answer of this question. That is C. That means the first one is absolutely true and the second one, the reason is false. Now we can go for the next one. Second assertion and reason. Magnetic field due to an infinite straight conductor varies inversely as the distance from it. You are studying in this chapter using Ampere's circuital law. The magnetic field due to straight conductor, that is B is equal to mu 0 by 2 pi I by R. That is the equation. Mu 0 by 2 pi I by R. That means R is in the denominator. So the magnetic field is inversely proportional to the distance. As the distance goes, magnetic field will be reducing. We'll go for, so assertion is absolutely correct. We go for the reason. The magnetic field in a straight conductor is in the form of concentric circles. That is absolutely correct. If this is the straight conductor, the magnetic field will be like this. The rule we can use it is Fleming's, that is right-hand thumb rule, isn't it? Not Fleming, right-hand thumb rule. That means this is a straight conductor. The curlings of the fingers will give the direction of the magnetic field. So it is forming the concentric circles. That is absolutely correct. But the reason is not the correct explanation for the assertion. So assertion and the reason are true, but the option is B. Why? Because it is not the correct explanation for the assertion. Now we'll move on to the third assertion and reason. That is the first one, we can say assertion. A rectangular current loop is an arbitrary orientation in external uniform magnetic field. No work is required to rotate the loop about an axis perpendicular to the plane of the loop. Why? Because when a circular loop, that means when a rectangular loop, any loop we can say, it is placed in a uniform magnetic field, they will experience a force. Tau is equal to NIAB sine theta. If theta is maximum, that means theta is 90 degree. They are getting maximum torque and they will rotate. Torque means it is the rotating effect of force. That is why they are rotating. So the absolutely correct assertion is absolutely correct. And what is the reason here? We can say all the positions represent the same level of energy. That is why they are rotating. Anywhere we can say they are rotating. So we can say no work is needed for rotating also. So here we can say assertion and reason are correct. And reason is absolutely correct explanation for the assertion. Now we can go for the next. We can say assertion. We will read first of all the assertion. The magnitude of the magnetic field in a region is equal to the number of magnetic field lines per unit area, where area should be normal to the field. You know that electric flux, what is electric flux? The number of lines per unit area. And those lines which is normally only we are taking into consideration. Similarly, magnetic field lines, we can say that all the magnetic field lines we will take and which is normal only we are counting. And the total per unit area, we'll call it as magnetic field intensity. That is magnitude of magnetic field. So that is absolutely correct. Assertion is absolutely correct. What is the reason behind? Magnetic field is tangential to the magnetic field line. That is also correct. But the reason is not the correct explanation for the assertion. Here, both are true, absolutely true. But the reason is not the explanation for the assertion. So here we can say the option B. That is the correct answer. Now we can go for the assertion and reason 5. Let us move on to that one. So if a proton and alpha particle enter a region, uniform magnetic field, perpendicularly with the same speed, the time period of revolution of alpha particle is double than that of the proton. What is the equation for the time period? Let us see that. What is the equation for the time period? We can say that the time period is equal to, let us see that. I can just write it out. Just a minute. Just a minute. I'll just write it. Yes. Yes, I can write it or not. I'll just check it. No. So here we can say T is equal to, I'm just explaining what is it. If a proton, just a minute, sorry for it. If a proton and alpha particle enter a uniform magnetic field perpendicularly with the same speed, the time period of revolution of alpha particle is double. How it is double? The time period T is equal to 2 pi m divided by BQ. 2 pi m divided by BQ, and that is very important equation. Time period is independent of, actually we can say, velocity and the radius, and that is very important. So here we can say it depends on the mass, magnetic field and the charge. So here proton and alpha particle, we are comparing with the proton and the alpha particle. Alpha particle, we can say it is absolutely the helium nucleus. So when we compare with the proton and alpha particle, we can say alpha is having 4 times the mass of the proton and the charge of alpha particle is twice that of the proton. That please keep it in mind. Now we can say when you are putting in the substitution T is equal to 2 pi m divided by BQ, we can say 4m divided by 2q will be in the case of the alpha particle. So 4 and 2 we can cancel, 2 remaining. That means twice we are getting, twice the time period of the revolution will be twice that of the proton. So assertion is absolutely correct. Now we can go for the reason. What is the reason? In a magnetic field, the period of the revolution of the charged particle is directly proportional to the mass and inversely proportional to the charge of the particle. That is absolutely correct. Why? Because T is equal to 2 pi m divided by VQ. T is proportional to mass and T is inversely proportional to the charge. So here we can say the both assertion and reason are true, and the reason is also the correct explanation for the assertion. Now let us move on to the 6th one. Assertion, we can say. A charged particle is moving in a circular path under the action of a uniform magnetic field. Why it is in a circular path? We know that when a charged particle enter into a uniform magnetic field, if it is perpendicular, if the velocity and the magnetic field is perpendicular, then only they will execute a circular path. Here we can say during the motion, kinetic energy of the charged particle remains constant. That is absolutely correct. Why? Because they are moving. Direction of velocity will be changing, but the velocity will be constant. And we can say kinetic energy also will be constant. So what is the reason here? Assertion is absolutely correct. What is the reason here? We can say during this motion, the magnetic force acting on the particle is perpendicular to the instantaneous velocity. That is absolutely correct. It is the centripetal force is provided by this magnetic force. It is perpendicular. That means it is towards the center. And the value of the velocity, instantaneous velocity at any instant, if you are taking the value of the velocity, if you want to get the direction of the velocity, you have to draw a tangent. So tangent and this force that is towards the center, it will be perpendicular. So that is why the magnetic force which is provided for the centripetal force and this instantaneous velocity is always perpendicular. So here we can say assertion and reason are true, and the reason is absolutely a correct explanation for the assertion. Let us move on to the seventh one. See that? Seventh one is when radius of a circular loop with carrying current is doubled, its magnetic moment becomes 4 times. What is the equation for the magnetic moment? M is equal to I into A. That means current into area. That is current into pi r squared. So if radius is increasing, magnetic moment r squared twice r. So 2 squared, 4 times it is increasing. Magnetic moment equation is very important. M is equal to IA. That means current into area. I into A. So that is why here we can say magnetic moment becomes 4 times. Now let us go for the reason. Magnetic moment depends on the area of the loop. Sure, magnetic moment depends on the current and the area of the loop. So assertion and reason are true. Reason is the correct explanation for the assertion. So here the answer is A, the option A. Now we'll move on to the next one, that is the 8th one. See that the magnetic field, the ends of a very long current carrying solenoid is half of that at the center. That means solenoid is very large. We can say that it will be half of that at the center. That means end will be less. Mu 0 Ni is the equation for the magnetic field at the center, and it is going at the, end, we can say divided by 2. So mu 0 Ni divided by 2. Now we can go for the reason. So assertion is correct. If the solenoid is sufficiently long, the field within it is not, is it uniform? Yes, it is correct. It is uniform. So here assertion and reason is correct. But can we say that if the solenoid is sufficiently long, that is why within it is uniform? It is not the reason, correct explanation for the assertion. So the option is B. Now we can go for the next one. If an electron and proton enter a magnetic field with equal momentum, momentum means mass into velocity, so that is same, then the paths of the both of them will be equally curved. Why? Because what is the equation for the radius? R is equal to mv divided by bq. From where you are getting this equation? This equation we can say that the centripetal force is provided by the magnetic force which is maximum. So mv squared by r is equal to qvb. Actually qvb sin theta, but theta is equal to 90 degrees, so qvb, maximum force they are getting. So when we are equating these two equations, we can be cancelled and r is equal to, we will get mv by bq. Here momentum remains constant, so the radius depends on the charge. And here we can say electron and proton is having same magnitude, so they will be equally curved. So assertion is absolutely true. And let us move on to the reason. The magnitude of the charge on an electron and the proton will be same. So that is the correct explanation for the assertion. So which is option A? The option A is the correct one. Let us move on to the last one. The coils of a spring we know, isn't it, come close to each other when the current is passed through it. Why? Because we can say this is correct only. Why? Because you can see that we'll just consider two parallel straight conductor. If you are allowing current through these two conductors, if it is in the same direction, what will happen? They will attract each other. So that is correct. If it is in the opposite direction, it will repel. That you are studying, and that is very important topic also. Then reason. What is the reason? We can say the coils of a spring carry current in the same direction, hence attract each other. That is also correct. So we can say both are true, and the reason is the correct explanation for the first one, assertion. So the option, it is A. So now that's all for the reason and assertion is over. Thank you for watching, children. Thank you.